Hello, everyone. Good evening, good morning. So, this is Raman. Right. So, welcome to this webinar, which is on Docker. Right. So, let me share my screen quickly. All right. So, we have the enough participant to start. All right. So, yeah. So, Cognitia. So, Cognitia is a company, right? It's a world's leading digital talent transformation company. We provide training on different platforms. So we are having around 150,000 plus professional trainers worldwide. So it's not only limited to India. So it is also worldwide training centers. So we already delivered the trainings in around 55 countries, over 7,000 industry veterans as instructors, okay, and around 500 plus customers. So we are not only providing the public batches, so Cognitia uh, is providing the training on the corporate level as well. So we are the authorized partners for Red Hat, Microsoft, Automation Anywhere, ITL. So we already have the center of excellence in machine learning, AI, microservices, RPA, IoT, big data, DevOps, cloud computing, cybersecurity, professional development, and PI technologies. So this webinar is mainly on the Docker. Okay. So my name is Raman. I'm having around 20 plus years of experience in IT industry as well as uh, actually it's more than in the training. So I will be presenting this webinar today. And if you have any question, you can put it on the chat window related to Docker. So I'm already a certified uh, Docker uh, in the Docker, that is DCA certifications. Also, I'm certified in Kubernetes, CK80 and CKA, okay, which is the Certified Kubernetes Application Developer and Certified Kubernetes Administration. So in this lecture, we will see what is the need of Docker, and we will see that how containerization application can be deployed by using Docker. We will see some highlights of the Docker features, like what is storage, what is Dockerfile. Okay, not in detail because we are only having the 1 hour webinar. So whatever I can cover, so I will cover here practically. Okay, so let us first understand that what is containerization and why it is required. For example, if I say that you need to deploy one application, okay? So what you need to do? You need to deploy one application. So consider you are not having the uh, you're not having containerization approach. What you will do? For example, you are having a web application to deploy or database application to deploy. Then you will, if I ask you, can you deploy this application? Consider you are a part of the implementation team, production team, operation team. And I ask you, this is the web application, can you deploy it? So you will say, okay, we will deploy it, but where to deploy? So you will say, okay, there is a virtual machine. Just deploy it on that virtual machine, which is a part of our data center, or maybe it is on the cloud. So I will provide you one virtual machine, for example. So let us first understand that what is the virtual machine type 1 architecture. So here, consider this is your physical system. So I'm just making it as a physical server. So physical server is nothing, but it is a machine where you want to deploy your virtual machines. Okay, so this physical server, it is having the infrastructure. What is the meaning of infrastructure? Infrastructure means the hardware. So you are having, for example, 1 terabyte hard disk, you are having 16 GB RAM. So that all comes under the infrastructure. If you are implementing the virtualization on top of that, then you need to, um, then what you need to do, you need to install hypervisor. What is hypervisor? There are many hypervisors, first of all. The main purpose of the hypervisor is to manage the virtualization. So on this physical system, if you are installing 3, 4, 30, 40, how many virtual machines you are having on this particular physical server, that is basically managed by the hypervisor. There are many hypervisors are there by different companies, like VMware from the VMware, right? So there is uh, there is Hyper-V from Microsoft. There is mm, Zen server from the Citrix, like that, right? There are many. So now this hypervisor is installed on top of your physical server. Then on top of that, we are having the guest operating system. What is guest operating system? So guest operating system is the virtual machine operating system, and it is a complete operating system with kernel. So what is the meaning of kernel? See, when we talk about a kernel of an operating system, it is everything for the operating system you can think. It is the heart of the operating system. If we don't have the kernel in an operating system, then operating system will not work, right? Because any hardware interaction by the application is through kernel only. So without kernel, you cannot imagine an operating system. For example, your application is running, and that application, when it runs, it needs some memory, it needs some CPU. So who will provide that communication? That is through the kernel. Okay, so kernel is very important part of the operating system. On top of that, we are installing some application binaries. What is binaries or libraries? For example, you are running an application which is Java based. Then Java runtime engine is required, so that operating system comes to know that there is something which is related to Java. I need to run this application. Right. So same way, uh, if something is running related to .NET or .NET Core, then your operating system should know that, okay, there is a runtime is already installed on my system, and that runtime is uh, to execute uh, the that particular application, which is .NET or .NET Core. So binaries or libraries is required to run your application. And on top of that, we are running our applications, right? So on a single operating system, there could be multiple application server, right? So let us see infrastructure. On top of this infrastructure, we are having hypervisor to manage the virtualization. On top of that, we are having guest operating system. On top of this guest operating system, we are having binaries and libraries. And on top of that, we are having the application. So this portion, right? So this is known as a virtual machine. So like that, there are multiple virtual machines which are running on top of which are running on top of this physical server, right? So, right now, right. So this particular portion, right? This particular portion, this is virtual machine. So this will be the approach which you are using if you don't have the containerization, right? To implement, right? So without containerization, you are doing this approach, and we call it virtual machine. Okay. Now, what is the need of containerization if we are going with this? See, we talk about the DevOps process. So in the DevOps process, basically, when we are having our end-to-end CI/CD pipeline, right? Whenever we are having our CI/CD pipeline. So in that case, the in that case, the physical or you can say in the case of the DevOps process, it is totally automatic process. There is no manual intervention is required. And we are running these days the modern applications like microservices. What is microservice? Microservice is something like that. For example, you are having one banking application, and this banking application needs some um, some modules like it needs internet banking, it needs, for example, withdraw service, right? It needs, for example, deposit service. It needs, for example, customer care service, right? So in this case, basically what happens if we put everything into a business application that is called the monolithic or tight coupling. So in the monolithic approach is not recommended these days. So how the developers are developing these applications? They are creating a separate uh, service for the internet banking. They are creating a separate service for withdrawal. They are creating separate service for deposit, and they are creating separate service for the customer care. And banking application is the consumer. So it is going to consume these services. Now, these services are to be deployed separately. Okay, these are to be deployed separately, and these are invoked by the banking application. Right? So this is how the modern approach. Now, internet banking is deployed separately. So now you can think that, okay, we will deploy on virtual machine. Why we need the containerization? As I mentioned that the DevOps process. Let me just give a quick picture of the DevOps process. So if I go to devopsworld.co.in, so this is DevOps, devopsworld.co.in. Okay. So, and here, if I go to the SDLC, so this is the DevOps process. So developer is pushing the code into some version control. It is automatically built by the build automation. It is automatically create a Docker image, right? So now, if we don't have this approach, if we eliminate this containerization approach in between, then what will happen? It looks like that it is we need the manual efforts to deploy our application if it is virtual machine. As I mentioned, this entire process, which is called the CI/CD pipeline. So this is not this CI/CD pipeline does not allow you to have any manual intervention. So developer is pushing the code, and once the code is into the production, it should be automatically get deployed. Okay. So in this case, if I put my virtualization right instead of containerization, then what will happen? So for example, you have deployed these applications like internet banking, withdraw, deposit on the virtual machine. Then if I say, okay, upgrade it, when you are updating it, then what will happen? You need to shut down this application and you need to deploy manually. And when you are doing this manual work, or maybe you are using some automation process, but it needs some downtime. Okay. In the DevOps process, downtime is not allowed. Okay. So the microservice approach will prevent the downtime. Okay, the changes are very, very minor. You will be surprised to see that how many times in a day Amazon is releasing the its application. So you can see Amazon deploys 23,000 times per day. So if you are going with this approach, the means you manually remove the version 1 and put the version 2. If this approach is used by the Amazon, they cannot do it in 23,000 times in a day. It means almost every 1 hour they are implementing 1,000 times. Right? So this is not possible if you are doing it with the approach of the manual intervention. So there will be definitely downtime. And if there is a downtime for these big companies, right, they cannot afford it. They cannot they cannot afford the downtime. For example, you are purchasing something from the Amazon and suddenly the application breaks. Then then you will not visit to that application again, right? Maybe if it happens one time, you can say, okay, it is exception. Second time, because if they are updating so frequently, right? So if you are getting a break in between when you are doing some shopping on this e-commerce website, then you know you will say, okay, I will leave this Amazon. I will take it from some other website. Okay, so they cannot afford. They lose their business. They lose their uh, millions of dollars. That's why the the replacement of this is the containerization. So in containerization, uh, containers are having something called container orchestration. And that container orchestration is nothing but those who are managing the containers. Means if the container is getting updated, it should be updated in a blue-green process. In the blue-green process, we are preventing a downtime. Right? So that is means when you go in detail, you will find a lot of features which are related to the containerization and container orchestration. So there are uh, there are so many features which are available, right? And these features you cannot get it in the normal virtualization. So right. So mm, right. So now how containerization works. So now consider I have this physical server, and on top of that, I'm having the infrastructure. So infrastructure again, this is nothing but this is the hardware. Right. On top of that, we are having one host operating system. Now, this host operating system can be a virtual machine. It can be directly installed on your uh, physical server, right? So that host operating system is a complete operating system with kernel. And on top of that, we are having something called Docker engine, Docker engine, which is running a process or a service, which is called Docker daemon. It is running Docker daemon. On top of that, we are running binaries. Okay, we are running binaries and libraries. Right? And on top of that, we are running our application. So what we are having? We are having infrastructure. On top of this infrastructure, we are having host operating system with kernel. And on top of that, we are having Docker engine. And then we are having binaries. And on top of this binaries, this application is running. So this portion, this is called container. Okay. So we'll discuss, let me just, so on a single system, you can run multiple containers, maybe 100, 200, 300, right? Now, uh, here you can see this is my one container, second container, third container, right? Fourth container. Right? So you can run many containers, right? So this portion, this is called container. Okay, so this is called container. Now this container is running with a Docker image. So we are talking more about Docker containers. There are many other container runtimes or tools are available. So it is running with a Docker image. Oh, what is Docker image? So Docker image is known as lightweight Docker images. What is the meaning of lightweight now? So lightweight means these are the images, right, which are built first of all without kernel. So what does it mean? See, here I have mentioned when you are running a virtual machine. So virtual machine is running with a kernel. So it's a complete operating system. But the one which we are running as a container is not a complete operating system. It is without kernel. So as I mentioned, kernel is the heart of the operating system. Linux kernel, Windows kernel, right? If you don't have the kernel, you don't have the operating system. Okay. So now these binaries, these binaries are nothing but the Docker images, right? And Docker images are without kernel. What does it mean? Means without kernel means if you are not understanding, let me try to explain you. For example, uh, you are running one application, and that application uh, is running without virtual machine or without operating system. Then applications says that if I run something, I need to interact with the operating system hardware. Now there is no kernel. How the kernel related activities will be provided to me? So now there is a Docker daemon. Docker daemon is nothing but a Docker service. So for example, I'm having one Ubuntu operating system, and here I don't have the Docker installed so far. Okay. So, oh, okay, Docker hyphen version, right? So Docker is not there. Let me install Docker. So I will say ABD update. I'm installing Docker on my Ubuntu machine. Right. So what it will do once the Docker is installed, it is going to install a service. So I'll say apt install docker.io -1. So now the Docker is getting installed on my machine. You can install Docker on your Windows also. Like I have a Docker service, Docker desktop service, which is running on my server. So right. So here you can see this Docker. This is on my system. Right? It is having images, volumes, etc. Now Docker is installed. So if I say system serial status, oh, status Docker. So you can see, yes, it is running as a service and it is running as a background service, right? Now, so this is nothing but a Docker daemon. This is what I'm talking about. So whenever a container is running, it needs any request. So that request will go to the Docker daemon. And host machine kernel is commonly shared with all the containers. So if there are multiple containers are running and they need the kernel activities, so this is commonly shared with this host machine kernel. So now the sometimes a question asks that the host machine, what type of host machine it is? Is it Windows, Linux? It can be anything, but it should be the latest one. So if you have the latest operating system, even though Windows operating system is its kernel is updated in such a way that it can support the containers. So now, how do we uh, how do we get the images? Okay. So because to run this container, we need the Docker images. Now to get the Docker images, you need a repository. So that repository is on means the one which I'm discussing here, Docker Hub, right? So in the Docker Hub, you can search the images. For example, I'm searching for Ubuntu. So Ubuntu is a official Docker image. See 1 billion plus download, 10K plus star. So if I go here, now I want to run a container by using a Docker image Ubuntu. So it is saying, okay, you can do this, but first you need to download a Docker image, which is Ubuntu with this command. So if I go here and if I say Docker and pull Ubuntu, so you can see I'm downloading a Docker image from the Docker hub. Now, if you see here, uh, Docker images, so you can see there is a Docker image which is Ubuntu there. And see the size, 76 MB. Ubuntu is 76 MB. What does it mean? Why it is so? Because if you download the Ubuntu operating system file, then you will notice that it is 5 GB, 6 GB, 10 GB. But here it is 76 MB because it is without kernel, and this Docker image is having only required files, right? So it is not having everything like a normal operating system. Now, can we deploy our application on this? Yes, we can deploy. For example, if I go, if I say Docker, if I create a container, Docker container run minus ID, name of the container, say web container, and I'm using a port forwarding to access this application externally. And if I say port 80 of my host machine is mapped with the port 80 of my container, and I'm running my Docker image, which is Ubuntu, right? Now this container is created. How do you know container get created? Docker container, right? ls. So you can see there is a Docker container is running at port number 80, right? Now, if I say, what is running at port number 80? I want to see. So at this moment, there is nothing running. If I go and take the public IP address of my machine, and if I go here, and if I say what is running at port number 80, so you will see there is nothing running. Why? Because Ubuntu is normal operating system. It by default, it doesn't run anything at port number 80. Right. Now, what I will do, I will go inside my container. I will say Docker exec minus ID. Name of the container is web. And what I want to do, I want to install, say Apache inside it. So I will say apt update. So now this command is basically going to install uh, exec command. I'm going inside the container and I'm executing this command. Next command, I want to install apt and install not Docker, Apache 2. Apache is one of the web server, Apache 2, this one. So now Apache is getting installed, right? So now Apache is getting installed. That is installing inside the container, okay? Right. Now I want to start this service. So I will say within my container, service Apache 2 and start. So now you can see Apache 2 is getting started. Now, if I go and if I refresh this, now you will see the default page of Apache is here, right? So if you see here that web, and if I say ls, and there is a special directory for Apache is where www and html. So this index.html file is basically, you can see here, okay, this is the output of this index.html. Consider your development team has given a code. I'm writing a very simple HTML code. I'm saying uh, this is funny HTML page. Okay, so yes, so I'm creating it into the test.html, right? So now you can see we have test.html. Now, how can I copy this file? So I will say Docker and copy test.html file to my container web at which path? Where www and HTML path. So now it is copied. So it means if I say here now slash test.html, so you will see that my funny page is here, right? So see, in few commands, I have deployed my application. I have deployed test.html, but it could be your jar file, war file. It can be your .NET Core. It can be anything, right? But yes, we have deployed our application as a container, right? So now, the application is running as a container. You say, oh, I need to stop. So you can say, Docker, stop, 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 stop. What to stop? Stop the container web. Now it is stopping my web service. It is not removing, it is just powering off the container. When it powers off, you will not be able to access your application. So if you see here, so now it is rotating and it is saying site cannot be reached. Why? Because application is stopped. So I will say Docker start. Wow. Right? No, come on. Oh, no, 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 no. It's not coming. The reason, because when I start, the Apache is not running. So I will say Docker and exec minus IT web and service Apache 2 and start. So now it is started. Let's run it. See, I can access my application. So these are, you see, very simple operations. Now, next question is that this Docker image. What is this Docker image and how it is basically making the impact, right? Means how can I create my custom Docker image? The one which I have downloaded from the Docker Hub, it is predefined, means someone has created, I have just downloaded it. If you want to create your own custom Docker image, you can do that. How can we do that? So we'll go and create a Docker file. Oh, Docker, D-O-C-K-E-R, Docker file. Okay. So I'm going inside this and I'm writing some code. So if you are wondering why I'm going to this website, so this is our website only. We are managing it. I'm the owner of that. So if I go to Docker, DevOpsWorld.com again, right? If I go to Dockerfile, right? So I'm going to copy this. Okay. So what is this? From Ubuntu. See, whenever you are creating a Docker image, right? Let me do one thing. Let me use another tool, which is the snipping tool, right? So let's copy this, right? Let's copy this and put it into our favorite tool, which is MS Paint, right? Let's put it here. Okay. Now here you can see that this is a script. See, whenever you are going for the automation without scripting, very difficult, right? If you really want to become a good DevOps engineer, be yourself comfortable in scripting, because that script you can give it to your CI/CD pipeline and that runs automatically. So custom Docker images is the image which you want to create. It can be done with the help of the Docker file. So we create a Docker image. So in the Docker image, so first thing is that we need a base Docker image. What is the base Docker image? Right. So base Docker image. See, whenever you are creating a Docker image, for example, when I have created this Apache container, so first, what I need? First, I need Ubuntu operating system. Right. So base Docker image is required. It can be any. It can be from your private registry. It can be from your Docker Hub. It can be from your Azure container registry. It can be from anywhere, but we need a base Docker image, because on top of that, we will add our instructions, which we are looking for the Docker file or Docker image, right? So step number one. So in this case, I'm using Ubuntu. So this Docker file I'm creating so that at the end, I will create a Apache Docker image. Okay. So okay. So next in, selection of base Docker image is very important, because on the basis of that, the Docker image size is defined. So if your base Docker image is big in size, right, you need to think a lot. It is not like a job which you are doing, whatever someone is saying, and you are a DevOps engineer, you need to follow blindly that. No, there is a lot of logic. You need to use a lot of logic if you want to become a good DevOps engineer. So here I cannot explain everything, right? Because there is a multi-stage Docker file where you can, put you are working with the development team, you are working uh, to reduce the Docker image size. Docker image size should be as minimum as possible. If it is big in size, then basically what happens means your container size will be big. And if you are running 100 containers, then it may impact the memory, uh, CPU, hard disk, so many things. So creating a Docker image is uh, very crucial, very important when you are creating as a DevOps engineer. No one else is going to create. You as a DevOps engineer, you need to know that. And in our training, right, we will see hundreds of, not hundreds of, hundreds is more. But if you see in this page, right, I have many examples, 3, 4, 5, multi-stage, 6, 7, 7, 8 examples. Once you go through this 7, 8 examples, right, so you will be very comfortable, right? That, oh, now I can write the Docker file by myself. But let's try to understand this. So this is the base Docker image. Rest of the thing depends upon the rest of the things. It depends upon the your requirement to requirement. So here I'm adding Apache 2 into this Docker image. I'm copying test.html. And I want when the containers get started from this Docker image, so it should start the Apache service. So that is what I'm doing. Okay. So let us do one thing. So let's save this. Now let me delete the container which I was having Docker rm minus web container. So when I have removed this container, right? So it is taking time. Okay. Okay. At last it is removed. So now once it is removed, now I cannot, where is my image? Here you go. Now I cannot access this, right? Because I have deleted the container. This application I was able to access because of that container. Now I will create a Docker image. How to create the Docker image? You can run a command Docker and build dot minus d. Let's call it web image. Now it is executing that Docker file, and right, it is executing this Docker file, and the Docker image is getting created. At the end, whatever we have written in that Docker file, everything clubbed together, and it will be the part of the Docker image. Don't worry about that red line which comes in between. Right. So yes, now it is right. Now if I say Docker and images, so you can see there is a web image, right? So this web image contains everything, whatever I have written in the Docker file. Now let us do one thing. If I say Docker and container ls, so you can see no container is running. Now I'm going to create a container, Docker container run minus ID. Name of the container, I'll say web container. I'm using a port forwarding. Port 80 of my host machine is mapped to port 80 of my container. And I'm using the Docker image, which is web image. Like this is created. Now, if I go here, not here, here, if I refresh this, so you can see I'm having my Apache and my test.html. Okay, so this will be very interesting, right? If you want to make make your career in the containerization, if you want to, if you are already working and you want to convert your application into the containerization, so this Docker image concept will be very interesting because you are playing how to create the custom Docker images, right? Now, another topic, which is the storage. Now consider this is my container Docker, and for example, uh, if your application is running and you want to keep your data into the container's memory, then you can use a storage system which is called temporary file system. So what is temporary file system? So I'll say, let me create a container, Docker container run minus IT, name of the container, I'll say C1, and I'm using a mount option, and I'm saying type equals to temporary file system, TMP temporary file system, comma. The source is not source. We need a destination. Destination means a container's directory, which is using this temporary file system. I'll give anything, say demo. So there is a directory in the container demo. If it is not there, it will be created. And I'm using a Docker image, say Ubuntu, right? Now, container is created. We can double check Docker PS or Docker container ls. So there is a C1 container. You can say C1. Okay. Now I will go inside the container. If I say Docker exec minus it C1, and if I say ls, so you can see there is a demo directory. If it is not there, it will be created. Now, if I say Docker exec, I want to see what is in the demo. It is blank. Let me create a file. So I will say Docker, and here I will say touch, and under demo, I want to create a file, say temp.java. Okay. So now if I say ls demo, so you can see there is a temp.java file, right? So now if I stop the container, as the Docker stop and container C1, so I'm stopping the container, right? After that, if you come back, you will see that this temp.java file will be removed if you start the container again. So you will find, so now if I say Docker start C1, right? So if I run this command again, so you can see temp.java file is deleted. Why? Because it was stored in the container's memory. When you stop your container, then the uh, when you stop the container, then the right. So when you stop the container, then the data also get deleted. So this is called non-persistent volume. But if you want to keep your data even though your container get deleted or stopped, then you need to use something called Docker volume. So if I say Docker and volume ls, so there is no volume, I'll create a Docker and volume create, say, demo volume. So I'm creating a Docker volume, Docker and volume ls. So there is a demo volume get created. Now if I create a container, Docker container run minus it and the name of the container, I will say C2, and I'll use a mount option, and I'll say source equals to demo volume, and destination equals to, okay, so this is a demo volume, this is destination, and destination is some directory, say demo1, and I'm using the Ubuntu image. Okay, now if I say Docker and exec minus it and C2, and if I say ls demo1, so this exists, but this is empty. Now, if I store some data, if I say Docker and exec minus it C2, and I'll create a file under demo1, say demo.jar, right? So now if I say ls demo1, so you can see it is there. Now, if I delete my container Docker and rm minus f C2, so container is getting deleted, but my data will not be deleted. So that data is basically get stored under a special directory where lib Docker volume demo volume, right, underscore data. So here my data. So now I can create another container, but this is managed by the Docker daemon. Okay, so this storage is managed by the Docker daemon. But if you want, it should be managed by your own directory. You want to create your own directory. That is called the bind mode. For example, I'm creating a directory called my directory. And if I say ls my directory, this is on my local system. This is blank. Now, what I will do, I will create a container Docker container and run minus it, the name of the container, I will say C3. And here I will use minus V option, and I'll say under home Ubuntu and my directory, it is mapped to container say demo2 directory. And I'm using Docker image, which is Ubuntu. Okay. Now C3 container is created. Now here I have mentioned demo2 directory. Now if I go to C3 container, so if I say Docker and exec minus it and I want to go inside the container C3. And if I say Docker exec minus IT C3, and so if I say ls and demo1, right? Demo2, demo2. So it is there, but it is not having any file. So what I will do, I will create a file. So I will say touch and create a file, which is demo2.java. Okay, so this is created. Now you can see there is a demo2.java. But this file is actually existing under my directory. When you are having your own directory, and in that directory, you want to store your data. Now, if my container get deleted, for example, if I say Docker and rm minus fc3, right? So now this is getting deleted. Deletion is taking time. Okay, deleted. Now, if I say ls, so you can see demo2.java file is here. So it means means container get deleted, but file is not deleted. You can create another container. You can point to this particular my direction. Let's go back to our presentation. So this is Docker. Okay, so this is the comparison between the virtual machines and containerization. This is the registry, right, from where we are basically downloading the Docker image. Docker host machine is the machine where the Docker daemon is running. Docker images, you may pull the images from the Docker hub for now for this demo, but there are other ways. Docker containers, we can start, stop, port forwarding, list, execute, remove, right? We can do a memory restrictions, so many operations. This is the example of the Docker file, which I have executed in this demo. And these are the storage, which is persistent and non-persistent. Temporary file system is non-persistent, Docker volume, bind, mount. These are the persistent storage drivers. All right, any question? Let me just go here. Guys, your feedback. Okay, okay. Uh, do Docker images have some network settings as a Docker engine? No, Docker images does not have the network settings. Docker containers have. Any other question, guys? We are about to end this. So, guys, do we have any meeting for OpenShift in the future? That you need to check with the support team. So, Cornell, maybe you can help Mogus. Any question related to the containers, Docker? All right. So if there is no question, so I'm done with this. Karnal, over to you. Is there any sample available for .NET deployment and configuration using containers, right? So there are some Docker images are available. Yes. If you go to Docker Hub, which is hub.docker.com, right? So you can search here .NET Course. You can see Docker as SDK .NET Core. There are many Docker images are available. All right, guys. So then that's it. And hope you have enjoyed this session. And we will meet probably in our training. Do the containers have the same IP as the kernel? No. It depends upon the networking. If you are using host network, then it will have the same IP address as the host machine IP address. So go to Docker Hub pages and search for Node.js. All right. So then that's it. Bye-bye.